A very general scenario, we have a master and a client here. This is not the Puppet master or the Puppet client. They are just two systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as system A. So system A sends over a client certificate to the master. Associated with this client certificate is the host name of system A. Now master goes through this certificate, it sees the host name and then it decides whether it wants to form a communication link with the system A. If it does, it signs the certificate and the signed certificate is sent back to system A. Now the system A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first three stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifest or even could be your files. So what happens after this request? After this request, the factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes your systems will be configured. So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines. And I have Oracle VM VirtualBox installed on my machine. So on that, I've simply created two virtual boxes, both CentOS 7, of course. So before we move on to the actual demo, I'll just take you through the various steps. So first, we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it'll sign this certificate. So once your master or the server signs the certificate, you can write your manifests. So the manifests are just the codes for configuration. And once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your catalogs, because as you know, the manifests are compiled into catalogs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text, and Puppet client here has a black background with green text. So we'll move on to server machine or the master machine because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys, under ENP0S3 in its value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall d, and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. this file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce this size. "512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet dash master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Signed certificate request here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp, which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets, we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalogs applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client. And this is the end of our demo.
So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
Now let's have a look at the Puppet community. The Puppet community is a rich community of a lot of people. Officially, there is no count. But counting the various channels where people collaborate, there are a little over 2,900 committers to GitHub projects who are directly or indirectly associated with Puppet Labs. There are 4,893 modules on the official Puppet Forge. These include modules from the Puppet Labs and also from open source contributors to GitHub. So that's nearly 5,000 modules of ready-made code available on the Puppet Forge. So before you write any code for Puppet, you can check to see if it's already been written by someone. Now there's a mailing list which has 6,588 participants. Apart from this, on Slack Overflow you have a big tag of Puppet Labs and Puppet, which gives you a list of only Puppet questions. That's a good playground for you to interact with people who are already using Puppet and who are contributing and helping others. Now let's have a look at Puppet Forge. So Puppet Forge is a GitHub client for a repository which is hosted by Puppet Labs. It has almost 5,000 modules of Puppet code. So these are both Puppet Labs and community contributed. The best thing about this is that they're easy to customize. So when you have a requirement for anything you're doing with your infrastructure, you can just grab one of those 5,000 modules, and then you can customize it according to your needs. One of the other benefits is they have built-in tests, so they follow all of the best practices. Now, if you write your own module, you also have to write your own tests, and you have to spend extra time writing best practice code. All of that has been taken care of, and you can just download any one of those and customize it according to your needs, and you're good to go. So that's the benefit you get from such a large community, where people contribute to the modules and the code and share with the community. Puppet DSL. Puppet DSL is a Puppet domain-specific language. It's the Puppet's primary programming language. It's just like plain English, and you don't really need to be a programmer to write code in it. It's kind of a subchild of Ruby because it approaches and uses is equal to and greater than marks to define things. So it's very easy to learn. You can specify packages that you want to install. You can specify services to be managed. You can do things based on the operating system that you have. So we'll be writing a small Puppet module which will be using this Puppet DSL. We will do that after we install the Puppet server and the client. And then we will write a simple Puppet module to show how to use the Puppet DSL. Let's have a look at the demo we are going to do. So you will be setting up the machines using sudo DNS because we want to have a resolvable DNS. Because only by having a resolvable DNS can we use Puppet, because Puppet uses the SSL certificates. Now we'll be installing the Puppet server and the client. We'll be signing the certificates of the client on the server side. And then we'll proceed with writing an NTP module, which we'll be using for installation of NTP on the client. And then we'll look at the Puppet programming language, or DSL. Now, we are going to look at a demo here. So we will be setting up the machines. We'll set up a sudo DNS locally because Puppet requires a fully qualified domain name in order to run, since there is a certificate communication taking place here. We will be installing the Puppet server, the Puppet client. We'll be signing the certificate, and finally we will write an NTP module and make it run. So now we will be starting a Puppet master and a client. I have two machines here. One is the Puppet master and the second is the Puppet client. The Puppet master has got almost 4 gig of RAM and 4 vCPUs, which I can show you here. Because it's a Ruby on Rails application, it requires a lot of CPU and RAM. For the client, I don't need that much RAM and CPU, so I've allotted 1 gigabyte of RAM and 1 vCPU. I will start both of these machines and find out the IP addresses. Right-click, normal start. Both of these machines are starting up. The Puppet client has started up, and the first thing I'll do is log in using root and Red Hat password, and then I will change the host name. So I'll say vim etc host name. This will open a hostname file in a text editor, which is vim. Then we'll do a dd, which will delete that existing hostname. Then I press the I for insert mode, and finally I'll type the puppet-client, which will be the host name of this machine. I'll save this file by doing escape !WQ ! And I'll reboot the machine. Similarly, going to the Puppet Master, I'll say root Red Hat. I'll open the hostname file. Say dd, then I'll say puppet-master. I'll save this file and reboot the machine for the hostname change to take effect. The hostname change does not take effect unless you reboot the machine. Now both of these machines are ready. I'm going to find out the IPs and use the Mac terminal to log into these. So this is 23 and 21. So 23 is my server and 21 is my client. I'll SSH to 23 first. Now, in order for the Puppet Master to be installed, I need a fully qualified domain name here and a fake DNS, which means a fully resolvable DNS name. So if I do host name here, you see my host name is Puppet Master. In order to set up a fake DNS, I need to go to the etc host file, go to the end, then I say IP address, host name local, then space host name. Now, this is one of the techniques which makes the Linux server believe that there's a fully qualified domain name on this machine. I'll save this. Then I do a host name -f. You see it has a fully qualified domain name now. So now we will be downloading the Puppet Labs repository for Ubuntu 16.04, which is Xennial. So I'll say curl -0 https apt.puppetlabs.com /puppetlabs-release -pc1 -xennial.deb. You can see there's a Debian file which has been downloaded here. I will import this using the dpkg command. So I'll say dpkg-i puppetlabs-release -pc1 -xennial.deb. And then I'll say apt-get update, which will update my apt package indexes on this machine. And now I'll install the Puppet server. So I'll say apt-get install puppet-puppet server-y. So the Puppet server is now installed, and we will be configuring the memory allocation for the Puppet server. So I'll say etc default Puppet server. So by default, it has only got 2 GB allocated. We'll give it 3 GB because it's JVM. I'll make this 3, and I'll change this to 3 as well. And I'll save this file. I'll make sure the unconfigured firewall allows port 8140, which is the Puppet Lab Puppet server port. The rules have been updated to allow that. I'll now start the Puppet server. So I'll say systemctl start Puppet server. It takes some time because it's a JVM, so it takes a couple of minutes to start the Puppet server. So the Puppet server is now running. I'll also enable it at boot time, so I'll say systemctl enable Puppet server. It will enable at boot time. Now I also need to configure a fully qualified domain name here. So I'll do that by going into the hosts file. I'll go to the end and I'll say 192.168.1.23 and then puppet-server.local and then puppet-server. If I do a hostname -f, put -master.local because the current hostname is puppet-master. So the trick is to have the hostname.local in front of the IP address in the host file. Having a fully qualified domain name now we will go to the client setup. The client setup is almost the same with just a small difference. The package which we need to install on the client is Puppet Agent. So we will go to the client. So you see this has got a host name. Now we also need to set up the fake DNS here. So I'll copy this host name, open the host line, go to the end, write the IP address, and then .local, and then host name again. So this will give me a fully qualified domain name. So when I do a host name, it says puppet-client. When I do a host name -f, it says puppet client local. To install the Puppet agent on this machine, I will need to download the Xenio packages. So I'll say wget https apt.puppetlabs.com/puppetlabs -release -pc1 -xenio.deb. I'll download this, and then I'll say dpkg-i puppetlabs-release -pc1 -xenio.deb. So this is the repository package which I'll be downloading here. And then I'll say apt-get update-y. This will update my apt caches on this machine. And now I'll finally install the Puppet agent. So I'll say apt-get install Puppet agent -agent-y. Now the Puppet agent is here. I'll start the Puppet agent and I'll enable it at boot time. So I'll say system control, start Puppet, then system control, enable Puppet. Now Puppet is enabled. Now we have set up the fully qualified domain name on the client and the server, but each of them should know each other. So we'll have to do a cross-certificate host mapping. So we will be copying the host file entry of the client and adding it to the server. So I'll go to the etc hosts on the server side. Go to the end, paste it there. Okay, and I'll be adding the entry of the master on the client side. Okay, now both of the servers will recognize each other now, because one of them has the host entry of the other. So if I do from the master ping puppet-agent.local, if I ping the agent from the server, -client.local, it is able to ping it. And if I ping the master from the client, if I say ping puppet-master.local, both of them will be able to ping each other. Now the next step would be to create a certificate signing request. So I'll go to my to this directory, which is opt puppet labs puppet bin, and I'll say puppet agent -t -server is equal to, and I'll give the fully qualified domain name of the puppet master. Then I'll say -f. When I do this, it will create a certificate signing request, you see. Now, if I go to the server and I do an opt, I'll check and see how many certificates are pending to be signed. You'll see there is a Puppet client certificate which is pending to be signed, which is denoted by the absence of a plus sign here. I'll be signing the certificate, so I'll say Puppet cert sign and then the name. So puppet-client.local. This will sign the certificates. And when I go to the server on the client side, if I run the Puppet agent again, you see it's actually pulling down the catalog. As of now, it has an empty catalog. That says there's nothing. Now we have configured the Puppet agent and the master. Now we will be taking a module from Puppet Forge. Puppet Forge is a big collection of open source modules which are free to use. As a first step, we will be using a ready-made module, and that would be a demonstration for how to actually get up and running with a module. So search for Apache module here. This is the Puppet Labs Apache module. I'll be using the Puppet command line, Puppet module install. This is the command for that. But I will make sure I run this command from the Puppet home. So I'll go to the master, I'll go to etc Puppet Labs, code, environments, production. In this, I'll do modules. Now I will run it from the binary which is present at the opt Puppet Labs bin Puppet. And then module install. Puppet Labs -Apache, and then this version. So we are specifying the latest version, and I'll hit enter. When I press enter, it starts downloading from the Forge API. So you see the module is downloaded in addition to the dependencies. So there is concat, stdlib, and Apache. So now I'll go to a folder here which is one level up called manifests. So this is the file here, etc Puppet Labs code environments production manifests. So in this there's a file which I'll be creating called site.pp. The site.pp will specify, and this is the main controller of how the infrastructure looks. In the site.pp, I specify that I want puppet-client.local node to have the Apache module included. I'll save this file, and the only thing I need to do now is, since all is set on the server side, I need to go to the client side and run Puppet agent. It will automatically download the Apache module and compile it, and then make sure the server is in a state. So when I press enter, we see a lot of output. It tries to configure Apache on this machine, and done. Now when I go to the front end of this machine, on this port, I should be able to see Apache's default page. So this is Apache's default page. So the module which we downloaded from the Forge was actually written in a way that Apache would be installed and run at boot time. So that is why it is running here. And that is all we have from the Puppet module. And this concludes the demo.
Today we're going to go through a real tough battle. We're going to decide which is better for your operations environment. Is it Chef, Puppet, Ansible, or SaltStack? All four are going to go head to head. So let's go through the scenario of why you'd want to use these tools. So let's meet Tim. He's our system administrator, and Tim is a happy camper putting and working on all of the systems in his network. But what happens if a system fails? If there's a fire, a server goes down? Well, Tim knows exactly what to do. He can fix that fire really easily. The problems become really difficult for Tim, however, if multiple servers start failing, particularly when you have large and expanding networks. So this is why Tim really needs to have a configuration management tool, and we need to now decide what would be the best tool for him, because configuration management tools can help make Tim look like a superstar. All he has to do is configure the right codes that allows him to push out the instructions on how to set up each of the servers quickly, effectively, and at scale. All right, let's go through the tools and see which ones we can use. The tools that we're going to go through are Chef, Puppet, Ansible, and SaltStacks. And we have videos on most of these software and services that you can go and view to get an overview or a deep dive in how those products work. So let's go and get to know our contestants. So our first contestant is Chef. And Chef is a tool that allows you to configure very large environments. It allows you to scale very effectively across your entire ecosystem and infrastructure. Chef is by default an open source code. And one of the things that you find as a consistent metaphor for the tools that we recommend on Simplilearn is to use open source code. The code itself is actually written in language of Ruby and Erlang. And it's really designed for heterogeneous infrastructures that are looking for a mature solution. The way that Chef works is that you write recipes that are compiled into cookbooks, and those cookbooks are the definition of how you would set up a node. And a node is a selection of servers that you have configured in a specific way. So for instance, you may have Apache Linux servers running, or you may have a MySQL server running, or you may have a Python server running. And Chef is able to communicate back and forth between the nodes to understand what nodes are being impacted and need to have instructions sent out to them to correct that impact. You can also send instructions from the server to the nodes to make a significant update or a minor update. So there's great communication going back and forth. If we look at the pros and cons, the pros for Chef is that there is a significant following for Chef, and that has resulted in a very large collection of recipes that allow you to be able to quickly stand up environments. There's no need for you to have to learn complex recipes. The first thing you should do is go out and find the recipes that are available. It integrates with Git really well and provides for really good, strong version control. Some of the cons, though, are really around the learning speed it takes to go from a beginner user with Chef to being an expert. There is a considerable amount of learning that has to take place, and it's compounded by having to learn Ruby as the programming language. And the main server itself doesn't really have a whole lot of control. It's really dependent on the communication throughout the whole network. All right, let's look at our second contender, Puppet. And Puppet is actually in many ways very similar to Chef. There are some differences, but again, Puppet is designed to be able to support very large heterogeneous organization. It is also built with Ruby and uses DSL for writing manifests. So there are some strong similarities here to Chef. As with a Chef, there is a master-slave infrastructure with Puppet, and you have a master server that has the manifests that you put together in a single catalog, and those catalogs are then pushed out to the clients over an SSL connection. Some of the pros with Puppet is that, as with Chef, there is a really strong community around Puppet, and there's just a great amount of information and support that you can get right out of the gate. It is a very well developed reporting mechanism that makes it easier for you as an administrator to be able to understand your infrastructure. One of the cons is that you have to really be good at learning Ruby again, as with Chef. The more advanced tasks really need to have those Ruby skills. And as with Chef, the server also doesn't have much control. So let's look at our third contender here, Ansible. And so Ansible is slightly different. The way that Ansible works is that it actually just pushes out the instructions to the server environment. There isn't a client server or master slave environment where Ansible would be communicating backwards and forwards with its infrastructure. It is merely going to push that instructions out. The good news is that the instructions are written in YAML, and YAML stands for YAML Ain't Markup Language. YAML is actually pretty easy to learn. If you know XML, and XML is pretty easy, if you know XML, you're going to get YAML really well. Ansible does work very well on environments where the focus is getting servers up and running really fast. It's very, very responsive and can allow you to move quickly to get your infrastructure up very fast. And we're talking seconds and minutes here, really, really quick. So again, the way that Ansible works is that you put together a playbook and an inventory, or you have a playbook. So the way that Ansible works is that you have a playbook, and the playbook, it then goes against the inventory of servers and will push out the instructions for that playbook to those servers. So some of the pros that we have for Ansible: we don't need to have an agent installed on the remote nodes and servers. It makes it easier for the configuration. YAML is really easy to learn. You can get up to speed and get very proficient with YAML quickly. The actual performance, once you actually have your infrastructure up and running, is less than other tools that we have on our list. Now, I do have to add a proviso. This is a relative less. It's still very fast. It's going to be a lot faster than individuals manually standing up servers, but it's just not as fast as some of the other tools that we have on this list. And YAML itself as a language, while it's easy to learn, it's not as powerful as Ruby. Ruby will allow you to do things that at an advanced level that you can't do easily with YAML. So let's look at our final contender here, SaltStack. So SaltStack is a CLI-based tool. It means that you will have to get your command line tools out or your terminal window out so you can actually manage the entire environment via SaltStack. The instructions themselves are based on Python, but you can actually write them in YAML or DSL, which is really convenient. And as a product, it's really designed for environments that want to scale quickly and be very resilient. The way that SaltStack works is that you have a master environment that pushes out the instructions to what they call grains, which is your network. And so let's step through some of the pros and cons that we have here with SaltStack. So SaltStack is very easy to use once it's up and running. It has a really good reporting mechanism that makes your job as an operator in your DevOps environment much, much easier. The actual setup, though, is a little bit tougher than some of the other tools, and it's getting easier with the newer releases, but it's just a little bit tougher. And related to that is that SaltStack is fairly late in the game when it comes to actually having a graphical user interface for being able to create and manage your environment. Other tools such as Ansible have actually had a UI environment for quite some time. All right, so we've gone through all 4 tools. Let's see how they all stack up next to each other. So let the race begin. Let's start with the first stage, architecture. So the architecture for most of our environments is a server-client environment. So for Chef, Puppet, and SaltStack. So very similar architecture there. The one exception is Ansible, which is a client-only solution. So you're pushing out the instructions from a server and pushing them out into your network, and there isn't a client environment. There isn't a two-way communication back to that main client for what's actually happening in your network. So let's talk about the next stage, ease of setup. So if we look at the 4 tools, there is one tool that really stands out for ease of setup, and that is Ansible. It is going to be the easiest tool for you to set up. And if you're new to having these types of tools in your environment, you may want to start with Ansible just to try out and see how easy it is to create automated configuration before looking at other tools. Now, and so with that said, Chef, Puppet, and SaltStack aren't that hard to set up either. And you'll find there's actually some great instructions on how to do that setup in the online community. Let's talk about the languages that you can use in your configuration. So we have 2 different types of language, with both Chef and Ansible being procedural in that they actually specify at how you're actually supposed to do the task in your instructions. With Puppet and SaltStack, it's decorative, where you specify only what to do in the instructions. Let's talk about scalability. Which tools scale the most effectively? And as you can imagine, all of these tools are designed for scalability. That is the driver for these kind of tools. You want them to be able to scale to massive organizations. What do the management tools look like for our 4 contenders? So again, we have a 2-way split. With Ansible and SaltStack, the management tools are really easy to use. You're going to love using them. They're just fantastic to use. With Puppet and Chef, the management tools are much harder to learn, and they do require that you learn some either the Puppet DSL or the Ruby DSL to be able to be a true master in that environment. But what does interoperability look like? Again, as you'd imagine, with the similar to scalability, interoperability with these products is very high in all 4 cases. Now, let's talk about cloud availability. This is increasingly becoming more important for organizations as they move rapidly onto cloud services. Well, both Ansible and SaltStack have a big fail here. Neither of them are available in the most popular cloud environments. And Puppet and Chef are actually available in both Amazon and Azure. We've actually just haven't had a chance to update our Chef link here, but Chef is now available on Azure as well as Amazon. So what does communication look like with all of our 4 tools? So the communication is slightly different with them. Chef has its own knife tool, whereas Puppet uses SSL, so Secure Sockets Layer, and Ansible and SaltStack use Secure Socket Hashing, SSH, as their communication tool. Bottom line, all 4 tools are very secure in their communication. So who wins? Well, here's the reality. All 4 tools are very good, and it's really dependent on your capabilities and the type of environment that you're looking to manage that will determine which of these 4 tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is. Please post in the comments below which tool you have decided to go with and what are the challenges that you're coming up with, because we'll help answer those challenges for you.
A very warm welcome to all our viewers. I'm Anjali from Simply Learn, and today I'll be showing you how you can install the configuration management tool Ansible. So let's have a brief about why one would use Ansible and what exactly is Ansible. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, a small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using 2 systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one thing we must remember with Ansible is that unlike Chef or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file, and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address 192.168.2.11. Once you have typed in your IP address, give a space and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this file and go back to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML is extremely simple to both write and understand. It's in fact very close to English. So now we'll write our playbook. The playbook or any code in YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file or the playbook in our case will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root's called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically an Apache server. So now my command's yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name, run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task. And the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats. And then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. And that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK. because this does not need to be changed, our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost. And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible.
Ansible today as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam, and like yourselves, Sam is a system administrator, and he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache, they could be database servers running MySQL. And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases for the simple reason that we're all human. As if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really allows you to create and control 3 key areas that you would have within your operations environment. First of all, there's IT automation. So you can actually write instructions that automate the IT setup that you would typically do manually in the past. The second is the configuration and having consistent configuration. Imagine setting up hundreds of Apache servers and being able to guarantee with precision that each of those Apache servers is set up identically. And then finally, you want to be able to automate the deployment so that as you scale up your server environment, you can just push out instructions that can deploy automatically different servers The bottom line is you want to be able to speed up and make your operations team more efficient. So let's talk a little bit about pull configuration and how it works with Ansible. So there are two different ways of being able to set up different environments for server farms. One is to have a key server that has all the instructions on, and then on each of the servers that connect to that main master server, you would have a piece of software known as a client installed on each of those servers that would communicate to the main master server and then would periodically either update or change the configuration of the slave server. This is known as a pull configuration. An alternative is a push configuration, and the push configuration is slightly different. The main difference is, as with a pull configuration, you have a master server where you actually put up the instructions. But unlike the pull configuration where you have a client installed on each of the services, with a push configuration, you actually have no client installed on the remote servers. You simply are pushing out the configuration to those servers and forcing a restructure or a fresh, clean installation in that environment. So Ansible is one of those second environments where it's a push configuration server. And this contrasts with other popular products like Chef and Puppet, which have a master-slave architecture with a master server connecting with a client on a remote slave environment where you would then be pushing out the updates. With Ansible, you're pushing out the service and the structure of the server to remote hardware, and you are just putting it onto the hardware irrelevant of the structure that's out there. And there are some significant advantages that you have in that you're not having to have the extra overhead weight of a client installed on those remote servers having to constantly communicate back to the master environment. So let's step through the architecture that you would have for an Ansible environment. So when you're setting up an Ansible environment, the first thing you want to do is have a local machine. And the local machine is where you're going to have all of your instruction and really the power of the control that you'd be pushing out to the remote server. So the local machine is where you're going to be starting and doing all of your work. Connected from the local machine are all the different nodes pushing out the different configurations that you would set up on the local machine. The configurations that you would write, and you would write those in code, are within a module. So you do this on your local machine for creating these modules, and each of these modules is actually consistent playbooks. The local machine also has a second job, and that job is to manage the inventory of the nodes that you have in your environment. The local machine is able to connect to each of the different nodes that you would have in your hardware network through SSH clients, so a secure client. Let's dig into some of the different elements within that architecture. And we're going to take a first look at playbooks that you would write and create for the Ansible environments. So the core of Ansible is the playbook. This is where you create the instructions that you write to define the architecture of your hardware. So the playbook is really just a set of instructions that configure the different nodes that you have, and each of those set of instructions is written in a language called YAML. And this is a standard language used for configuration server environments. Did you know that YAML actually stands for YAML Ain't Markup Language? That's just a little tidbit to hide behind your ear. So let's have a look at one of these playbooks it looks like. And here we have a sample YAML script that we've written. So you start off your YAML script with 3 dashes, and that indicates the start of a script. And then the script itself is actually consistent of 2 distinct plays. At the top we have play 1, and below that we have play 2. Within each of those plays we define which nodes are we targeting. So here we have a web server in the top play, and in the second play we have a database server that we're targeting. And then within each of those server environments, we have the specific tasks that we're looking to execute. So let's step through some of these tasks. We have an install Apache task, we have a start Apache task, and we have an install MySQL task. And when we do that, we're going to actually execute a specific set of instructions. And those instructions can include installing Apache and then setting the state of the Apache environment, or starting the Apache environment and setting up and running the MySQL environment. So this really isn't too complicated, and that's the really good thing about working with YAML, is it's really designed to make it easy for you as an operations lead to be able to configure the environments that you want to consistently create. So let's take a step back though. We have two hosts. We have web server and database server. Where do these names come from? Well, this takes us into our next stage and the second part of working with Ansible, which is the inventory management part of Ansible. So the inventory part of Ansible is where we maintain the structure of our network environment. So what we do here is part of the structure in creating different nodes is we've had to create two different nodes here. We have a web server node and a database server node. And under web server node, we actually have the names that we're actually pointing to specific machines within that environment. So now when we actually write our scripts, all we have to do is refer to either web server or database server, and the different servers will have the instructions from the YAML script executed on them. This makes it really easy for you to be able to just point to new services without having to write out complex instructions. So let's have a look at how Ansible actually works in real world. So the real world environment is that you would have the Ansible software installed on a local machine, and then it connects to different nodes within your network. On the local machine, you'll have your playbook, which is the set of instructions for how to set up the remote nodes. And then to identify how you're going to connect to those nodes, you'll have an inventory. We use secure SSH connections to each of the servers, so we are encrypting the communication to those servers. We're able to grab some basic facts on each server, so we understand how we can then push out the configure that server remotely. The end goal is to have an environment that is consistent. So let's ask you a simple question. What are the major opportunities that Ansible has over Chef and Puppet? Really like to hear your answers in the comments below. Pop them in there and we'll get back to you, and really want to hear how you feel that Ansible is a stronger product, or maybe you think it's a weaker product as it compares to other similar products in the market. Here's the bonus. We're going to talk a little bit about Ansible Tower. So Ansible Tower is an extra product that Red Hat created that really kind of puts the cherry on the top of the ice cream, or is the icing on your cake. Ansible by itself is a command line tool. However, Ansible Tower is a framework that was designed to access Ansible. And through the Ansible Tower framework, we now have an easy to use GUI. This really makes it easy for non-developers to be able to create the environment that they want to be able to manage in their DevOps plan without having to constantly work with the command prompt window. So instead of opening up terminal window or a command window and writing out complex instructions only in text, you can now use drag and drop and mouse click actions to be able to create your appropriate playbooks, inventories, and pushes for your nodes. All right, so we've talked a lot about Ansible. Let's take a look at a specific company that's using Ansible today. And in this example, we're going to look at Hootsuite. Now, Hootsuite, if you've not already used their products, and they have a great product, Hootsuite is a social media management system. They are able to help with you managing your pushes of social media content across all of the popular social media platforms. They're able to provide the analytics. They're able to provide the tools that marketing and sales teams can use to be able to assess a sentiment analysis of the messages that are being pushed out. Really great tool and very popular. But part of their popularity drove a specific problem straight to Hootsuite. The challenge they had at Hootsuite is that they had to constantly go back and rebuild their server environment, and they couldn't do this continuously and be consistent. There was no standard documentation, and they had to rely on your memory to be able to do this consistently. Imagine how complex this could get as you're scaling up with a popular product that now has tens of thousands to hundreds of thousands of users. This is where Ansible came in and really helped the folks over at Hootsuite. Today, the DevOps team at Hootsuite write out playbooks that have specific instructions that define the architecture and structure of their hardware nodes and environments, and are able to do that as a standard product. Instead of it being a problem in scaling up their environment, they now are able to rebuild and create new servers in a matter of seconds. The bottom line is Ansible has been able to provide Hootsuite with IT automation, consistent configuration, and free up time from the operations team so that instead of managing servers, they're able to provide additional new value to the company.
Ansible is currently the most trending and popular configuration management tool, and it's used mostly under the DevOps approach. So what will you be learning today? You'll learn why you should use Ansible, what exactly is Ansible, the Ansible architecture, how Ansible works, the various benefits of Ansible, and finally we'll have a demo on the installation of Apache or the HTTPD package on our client systems. We'll also be hosting a very simple web page, and during this demo I'll also show you how you can write a very simple playbook in YAML and your inventory file. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured, and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting two virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these two machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the two. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of a client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing we need to check if the syntax of our YAML file is absolutely right because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed, as you can see here, gathering facts. That's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go. Your Apache server is installed and your web page is hosted.
Hey there! Are you exploring test automation? Are you wondering why everyone is talking about Selenium around you? Do you want to know what Selenium is all about? If yes, this is the video for you. What should you expect from this video? Before you start understanding any automation tool, it's good to look back into what manual testing is all about, what are its challenges, and how automation tool overcomes these challenges. Challenges are always overcome by inventing something new. So let's see how Selenium came into existence and how did it evolve to become one of the most popular web application automation tool. Selenium suite of tools. Selenium is not a single tool. It has multiple components. So we will look into each of them. And as you know, every automation tool has its own advantages and limitations. So we will be looking at what the advantages are and the limitations of Selenium and how do we work around those limitations. Alright, so let's get started. Manual testing. A definition, if you can say, a manual testing involves the physical execution of test cases against various applications and to do what? To detect bugs and errors in your product. It is one of the primitive methods of testing a software. This was the only method which we knew of earlier. It is execution of test cases without using any automation tools. It does not require the knowledge of a testing tool, obviously because everything is done manually. Also, you can practically test any application since you are doing a manual testing. So let's take an example. So say we have a use case. You are testing, say, a Facebook application. And in Facebook application, let's open the Facebook application and say create an account. This is your web page which is under test now. Now as a tester, what would you do? You would write multiple test cases to test each of the functionalities on this page. You will use multiple data sets to test each of these fields like the first name, the surname, mobile number or the new password. And you will also test multiple links. What are the different links on this page, like say forgotten account or create a new page. So these are the multiple links available on the web pages. Also, you look at each and every element of the web page, like your radio buttons, like your drop down list. Apart from this, you would do an accessibility testing. You would do a performance testing for this page or say a response time after you say click on the login button. Literally, you can do any type of tests manually. Once you have these test cases ready, what do? You start executing these test cases one by one. You will find bugs, your developers are going to fix them, and you will need to rerun all these test cases one by one again until all the bugs are fixed and your application is ready to ship. Now, if one has to run test cases with hundreds of transactions or the data sets and repeat them, Can you imagine the amount of effort required in that? Now that brings us to the first demerit of the manual testing. Manual testing is a very time consuming process and it is very boring. Also, it is very highly error prone. Why? Because it is done manually and human mistakes are bound to happen. Since it's a manual execution, testers' presence is required all the time. One needs to keep doing manual steps, step by step again all the time. He also has to create manual reports, group them, format them so that we get good looking reports. Also send these reports manually to all stakeholders. Then collection of logs from various machines where you have run your test, consolidating all of them, creating repositories and maintaining them. And again, since it's all is a manual process, there is a high chance of creating manual errors there. Scope of manual testing is limited. For example, let's say regression testing. Ideally, you would want to run all the test cases which you have written. But since it's a manual process, you would not have the luxury of time to execute all of them, and hence you will pick and choose your test cases to execute. That way, you're limiting the scope of testing. Also, working with large amount of data manually is impractical, which could be the need of your application. What about performance testing? You want to collect metrics on various performance measures as a part of your performance testing. You want to simulate multiple loads on application under test, and hence manually performing these kind of tests is not feasible. And to top it all up, say if you're working in an agile model where code is being churned out by developers, testers are building their test and they're executing them as and when the builds are available for testing. And this happens iteratively. And hence, you will need to run this test multiple times during your development cycle, and doing this manually definitely becomes very tedious and boring. And is this the effective way of doing it? Not at all. So what do? We automate it. So this tells us why we automate. 1, for faster execution. 2, to be less error prone. And 3, the main reason is to help frequent execution of our test. So there are many tools available in the market today for automation. One such tool is Selenium. Birth of Selenium. Much before Selenium, there were various tools in the market like say RFT and QTP, just to name a few popular ones. Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks and he was working on a web application which needed frequent testing. He realized the inefficiency in manually testing this web application repeatedly. So what